Okay, so this is the 2025 Ordinary Level Maths Paper 1, and this is question 1. So Sean is buying a power bank and a USB cable. One power bank costs €30 before VAT at 23%, and then we have to find the cost of the power bank after VAT has been added. So it costs €30 before VAT. We have to increase that by 23%. So what we're going to do is we're going to multiply by 1, which will leave it at 30, and then an extra 0.23 or 23%. When you do that, you get €36.90. So that's part 1. Let's have a look at part 2. Sean is going to buy a different power bank that costs €26 and a USB cable that costs €9. Sean sees a special offer to buy the power bank and USB cable together for €28. Work out the percentage discount of this offer. So the power bank and the cable, if he was to buy them separately, would be €26 plus 9, which is €35. So let's see, he could get them for 28. So the discount is €35 minus 28. So that's €7. So we're looking for the percentage discount. The percentage discount is the discount, which is €7, divided by what he would have paid originally if he bought them separately, which is €35. We got to multiply that by 100 to convert it into a percentage. So when you do that, you will get 20%. So he can get a 20% discount by buying them on the special offer. Okay, next one then. Mairead can clean a standard window in 9 minutes. Dermot can clean a standard window in 12 minutes. Mairead and Dermot both start cleaning standard windows at the same time. They both finish cleaning a window at the same time. After how many minutes will this first happen? So if we start with, if we have a look, we have Mairead and we have Dermot. And let's take window number 1. Mairead will take 9 minutes and Dermot will take 12 minutes. Take window number 2 then. Mairead will be finished in 18 minutes. Dermot will be finished in 24 minutes. We take window number 3. Mairead will be finished in 27 minutes. Another 9 minutes added on. And then Dermot will be finished in 36 minutes. If we take window number 4, Mairead will be finished in 36 minutes. And actually we can see that Dermot will be finished window number 3 in 36 minutes. So Mairead will be finished 4 windows in 36 minutes. Dermot will be finished 3 windows in 36 minutes. But they will both finish cleaning a window at the same time after 36 minutes. So the answer is 36 minutes. Okay, so next one then. A building has 35 standard windows. Work out how long it would take Mairead and Dermot to clean the 35 windows if they both work together. So if we look at this table up here, we can see we've got Mairead finishing window after 9, 18, 27 and 36 minutes, Dermot 12, 24, 36 and so on. So they will both finish 7 windows in 36 minutes. So 1, 2, 3, 4, 5, 6, 7. So 7 windows in 36 minutes. Okay, so we've got to work out how long it would take Mairead and Dermot to clean 35 windows. So if we take 35 and divide it by 7 windows, that's 5. So there are 5 of these 7 windows that they finish in 36 minutes, or there are 5 36 minutes required to do the 35 windows. So we need to take the 36 and multiply it by 5, and that is 180 minutes in total, or 3 hours. It'll take them 3 hours to do the 35 windows. That's question 1 finished. This is question 2. Let's see, in this question, I squared is minus 1. Z1, Z2, and Z3 are 3 complex numbers. Z1 is minus 1 plus 2i, Z2 is 2 plus 3i, Z3 is 4 minus i. The complex number Z1 is shown on the Argand diagram. That's here, so that's minus 1 plus 2i. Plot and label Z2 and Z3 on the same Argand diagram. So for Z2, we've got 2 plus 3i. So the real part is 2, so we've got to come out along here 2, and then the imaginary part is 3, so 3i. So you got to come up along here. So it's going to be here. So let's just plot that. So it's 2 plus 3i. So this is Z2. And then we've got, let's see, 4 minus I for Z3. So come out along here, 4, go down 1. It's going to be down here. This is Z3. Okay, next part of this question. Work out the modulus of Z1. That is, find the modulus of Z1. Give your answer in third form. So Z1 is minus 1 plus 2i. So let's just write that down. Z1 is equal to minus 1 plus 2i. So to do the modulus of Z1 then, you take the square root of this number here, which is minus 1, and square it. Plus then you take this number, including the sign, so it's plus 2, which we've got to square. So it's basically the square root of a squared plus b squared. You don't include the I. So here we've got the square root of minus 1 is plus 1, the square root of plus 2 is plus 4. So our answer is just the square root of 5. Okay, so the next question then is to write down one possible value of Z4. Now we're told here the modulus of Z4 is less than the modulus of Z1. So we need a complex number that will give us a modulus that's less than square root of 5. Z1 was minus 1 plus 2i. So what I'm going to go for is 1 plus 1i. I'm going to use smaller numbers, or at least this one is smaller anyway. So the modulus then, so this is Z4. So the modulus of Z4, you don't have to do this, but just to check it, would be the square root of 1 squared plus 1 squared. So that's the square root of 2. And the square root of 2 is smaller than the square root of 5. So this is my answer here, 1 plus 1i. Okay, next one then. U and V are two complex numbers that were given here. Write U over V and rewrite it in this form here. So this is really division of complex numbers. So we want U on the top, so it's 4 minus 6i on the top. On the bottom we want 1 plus I. Now the way you do this then is to multiply this fraction here by the complex conjugate of what's on the bottom, the denominator. The complex conjugate of the denominator is 1 minus I. 1 plus I is on the bottom. Its conjugate is 1 minus I. So you multiply it by 1 minus I over 1 minus I. Now that's just really 1. Anything divided by itself is just 1. So we're multiplying the fraction by 1, which doesn't change it, but it's just going to change the way it looks. So let's do that then. So we're going to do the top line first. 4 times 1, 4. 4 times minus I is minus 4i. Minus 6i times 1 is minus 6i, and then minus 6i times minus 1i is plus 6i squared. And then we got to put all that over. We've got to multiply out the bottom. So 1 times 1 is 1. 1 times minus I is minus I. I times 1 is plus I, plus 1 times I. And then we have plus I times minus I. Well, plus times minus is minus. I times I is I squared. Okay, let's just simplify the top line. On the top, we have minus 4i minus 6i. That's minus 10i anyway. And then we have this 6i squared. Now, I squared is just minus 1. So it's really 6 times minus 1. So 6 times minus 1 is just minus 6. So that'll be minus 6 out here at the end. This bit out here is just minus 6. So we have plus 4 minus 6. That's minus 2. On the bottom then we have minus I plus I. And then again we have this I squared out here, minus I squared. So if you look at minus I squared, well, I squared is just minus 1, so that's minus 1, which is just plus 1. So this here is just plus 1, and we have plus 1 here, so that's plus 2. So I'm just going to divide these in then. I'm going to divide the 2 into the 2 and the 2 into the minus 10. So we'll do the number first. 2 into minus 2 is minus 1, and 2 into minus 10 is minus 5. So that's my answer there. That's in the form a plus bi. And that's it for this question. Okay, next question. Question 3. Ricky is buying protein bars. The cost of a single protein bar is $3.30. The shop has the following 2 special offers. So in offer A, 3 bars for the price of 2. In offer B, a 12 pack of the same bar for $29.99. Which offer is the cheaper per bar? Use calculations to support your answer. The cheaper per bar. So let's work out how much each one would cost per bar. So let's take offer A and work out how much it would cost per bar. $3.30 per bar. Let's multiply that by 2 because it's the price of 2 bars. So that's €6.60. So you get 3 bars for €6.60. So if you take €6.60 and divide it by 3, that tells you how much each bar is. Well, 3 into 6 is 2, 3 into 6 is 2. So you'll get each bar for €2.20. So let's look at offer B. So in this case, you get a 12 pack of the same bar for $29.99. So if you take €29.99, divide that by 12, it'll tell you how much you're paying for each bar. So when you take $29.99 divide by 12, you'll get €2.50 when it's rounded to 2 decimal places there per bar. So this one here would be cheaper, offer A, because you're getting them for $2.20 per bar, whereas in offer B you have to pay $2.50 per bar. Okay, so let's try the next question. Solve the inequality. So we have 2x plus 4 greater than or equal to 6x minus 8. So what I'm going to do is I'm going to take the 2x and I'm going to bring it over to the other side. In other words, I'm going to subtract 2x from the left-hand side to leave me with just 4. I'm going to subtract 2x from the right-hand side. So 6x minus 2x is 4x. And I have minus 8 there as well. Next thing I'm going to do is I'm just going to get rid of that 8 on the right-hand side. So I'm going to add 8 to both sides because it's a minus 8. So if I add 8 to the right-hand side, I'll just get 4x. If I add 8 to the left-hand side, I'll get 12. And then finally, that 4 is multiplied by the x. So I'm going to divide by 4, get rid of it, and then divide 12 by 4, I'll get 3. So x is less than or equal to 3 is the answer. Okay, next question. Some number k times some number t is equal to 12. Write down a possible value for k and a corresponding value for t. Well, there are a few different answers here. We could say k is equal to 3. That means we'd have to let t equal to 4. 3 times 4 will give you 12. That's what I'm going to use. But you could use 2 and 6. You could use 1 and 12. So a few different answers. So k is 3, t is 4 is what I'm going to use. Use your values for k and t from part C1 to find the value of b in the following equation. So we have x plus k. We've got to multiply that by x plus t. And our answer is x squared plus bx plus 12. So on the right-hand side, we have everything except this number here, which is what they want us to find. So let's see if we can work it out. On the left-hand side, we've got x plus, they want us to use the value for k that we got up here. So that's 3. And x plus this value here, then 4. Let's multiply those out. So that gives us, let's see, x times x, which is x squared. X times 4, which is 4x. 3 times x plus 3x plus 3x times plus 4 plus 12. So what we get is x squared. We can add these two here. They're both x's. So 4x plus 3x is 7x. And we have plus 12. So this is exactly the same. This thing down here is exactly the same as this up here. But we have a b here in front of the x. Here we've got a 7 in front of the x. And we were told that this is equal to this on the left-hand side. So this here is equal to this is equal to this. So 7 must be b. So b is equal to 7. That's it for this question. Okay, let's look at question 4. Solve the following equation. 5a minus 3 is equal to 2a plus 7. Okay, so let's just write that down. So we have 5 times a minus 3 is equal to 2a plus 7. Multiply them out. So 5 times a is 5a. 5 times minus 3 is minus 15. And that's 2a plus 7 on the right-hand side. So let's take this 2a on the right-hand side, subtract 2a from both sides to get rid of it. So if I subtract 2a from 5a, I'll get 3a on the left-hand side, minus 15. If I subtract 2a from 2a, I'll get 0. So that'll just leave me with 7 on the right-hand side. So let's get rid of this 15 next. So let's add 15 to both sides. Because it's minus 15, we're going to add 15. So we'll be just left with 3a on the left-hand side, and we'll be left with 22 on the right-hand side. When you add 15 to 7, you get 22. Next thing we're going to do is we have this 3 stuck to the a here, which means it's multiplied by the a. So we need to divide by 3. Divide by 3 will give us 1a. Divide 22 by 3, you'll just get 22 over 3. That's really it for this part of the question. Let's look at the next one. The function f of x is defined as f of x equal to x cubed minus 3x squared plus 4x minus 8. X is real. Find f prime x, the derivative of f of x. Hence find the slope of the tangent to f of x at a point 2 minus 4. So we have f of x here is equal to x cubed minus 3x squared plus 4x minus 8. So we want to differentiate the x cubed. So what you do is you take the 3, bring it down in front of the x, and then reduce the power by 1 to 2. Minus, take the 2, if we were looking at the 3x squared now, take the 2, bring it down in front of the 3. 2 3s are 6, so you write down 6. Write down the x, reduce the power 2 down to 1. So that's just 6x to the power of 1. With the 4x then, the x is to the power of 1. Take the 1, bring it down, multiply it by the 4. So that'll give you 4. Reduce the power by 1 will actually give you x to the power of 0, which is just 1. So 1 times 4 is 4. If you differentiate a constant, the 8, the minus 8 there, you'll just get 0. So this is what you get when you differentiate the function. Now the slope of the tangent, we have a point 2 minus 4. So that means x is 2. So this is x, this is y. So all you got to do, the slope of the tangent is going to be 3 times, put the 2 in instead of the x. So it's going to be 2 squared minus 6 times 2 plus 4. That'll give us, let's see, you must do the power first. 2 2s are 4. 3 4s, 12. Minus 6 times 2 minus 12 plus 4. And that'll finally just give you a slope of 4. Okay, let's look at the next question. So we have C here, and we have the diagram below shows the graph of a cubic function g of x. P, Q, and R are the points on the graph of g. Write each of the letters P, Q, and R in the correct place in the table so that each point matches the description of the derivative at that point where g prime x is the derivative of g of x. So the first one here, we have g prime x being negative, means that the tangent will slope in that direction. It'll have a negative slope. If it was positive, the tangent would look like that. It would slope in that direction. So we want a negative slope. So we want the tangents to look like this. And the only place that can happen is, with those 3 points, if you were to draw a tangent, would be at Q. Now, g prime x equal to 0 means the tangent has to be horizontal. It has to have a 0 slope. And the only place the tangent can be horizontal would be here at P. So we're looking at P being here. And then a positive slope, this final one here, g prime x is positive, greater than 0. Well, that means the tangent would slope in this direction. So that would be or here. Okay, so that's it for that question. For the point that you match to g of x, g prime x is equal to 0, give a reason for your answer. So that would be this one up here, where we have a horizontal tangent. So you can say there are any number of ways of saying this. but we could say something like the slope of the tangent at the point P would have to be 0, since g prime x is equal to 0. So the tangent is horizontal. Okay, something along those lines anyway would suffice. Okay, so that's it for question 4. Okay, let's look at the next question. Question 5, use algebra to solve the simultaneous equations. Okay, so we have 3x plus 2y is equal to 11. That's equation number 1. We have x minus 4y is equal to minus 1. That's equation 2. What I'm going to do is take equation 1 and I'm going to multiply it by 2. You'll see why in a second. Let's take 3x, multiply it by 2. That'll give us 6x. Take the 2y plus 2y. That'll give me plus 4y. Take the 11, multiply it by 2. That'll give me 22. So if I take equations 1 and 2 and add them, you can see here that I've got a minus 4y and I've got a plus 4y. So these will cancel when I add them. That's why I multiplied this by 2 to bring it up to plus 4y, because I knew I had a minus 4y here. So let's add these two. 6x plus 1x is 7x. These will give me 0, and over here I'll end up with 21. Now I have 7x is equal to 21. So to get rid of that 7, because it's multiplied by the x, I've got to divide by 7. So x is equal to 21 divided by 7, which is 3. Let's take equation 1 then. Well, let's take equation 2. It looks a bit easier. X minus 4y is equal to minus 1. Let's stick in x. Well, 3 is x. So we've got minus 4y is equal to minus 1. I have a 3 there I want to get rid of, so it's a plus 3, so subtract 3. That'll leave me with minus 4y is equal to minus 4. Minus 1 minus 3 is minus 4. And then finally that minus 4 is multiplied by that y, so I need to divide by minus 4. So divide by minus 4 will get rid of it. Divide minus 4 by minus 4 will give you plus 1. So x is equal to 3, y is equal to 1. There are my two answers there. Okay, next question then. Solve the following equation. Give your answer correct at 2 decimal places. Now, when it says give your answer correct at 2 decimal places for a quadratic expression, it means really you've got to use the minus b formula, the quadratic formula. So I'm going to just write it down first. So it's minus b plus or minus the square root of b squared minus 4ac all over 2a. So if you write down a, b, and c as well. So a is the coefficient of the x squared, which is 3. B is the coefficient of the x, which is minus 2. And c is the number independent of x with no x attached to it, which is minus 4. Let's put those in. We got minus b. Well, minus 2 is plus 2. Plus or minus the square root of minus 2 squared minus 4 times a, which is 3, times c, which is minus 4. And that's all over twice 3. So let's do all this then. Let's just do what's underneath the square root symbol first. But actually I'll do the denominator first. 2 3s are 6. Now if we take minus 2, we've got to square that. Minus 2 times minus 2 is plus 4. The rest of them then, you've got a minus times a plus times a minus. So you have a minus here times a plus here times a minus. Well, minus times plus will just give us minus. And that minus times this minus will give us plus. So this is going to be plus. After that, it's 4 times 3 times 4. Well, 3 4 is 12 and 4 12s 48. So my two answers are 2 plus and minus the square root of 52 over 6. So that just means that x is equal to 2 plus the square root of 52 over 6. Which is, we have to give this to 2 decimal places. If you can just do that on your calculators, you'll get 1.54 to 2 decimal places. And x is equal to 2 minus the square root of 52 over 6. Again, on your calculator to 2 decimal places, that'll give you minus 0.87. Okay, so next question then. The graph of the quadratic function h of x is shown in the diagram below, drawn to scale. The graph is symmetrical about a vertical line. So there's a vertical line coming down here, and it cuts through the bottom here, the vertex, and it cuts the graph in half. Based on the graph, which of the following pairs of values of x is a possible set of roots for h of x? That is the values of x for which h of x is equal to 0. So what they're asking for here is a value here, What value do you think that might be? And what value do you think this might be here? Well, if we take 2 and 8, they're two positive numbers. So two positive numbers would have to be out here somewhere to the right of the y-axis. So it couldn't be this one. The second one, two negative numbers, x is minus 2 and x is minus 8. That means they would have to be down here somewhere to the left of the y-axis. The fourth one is minus 8, 2. Well, minus 8 is bigger than minus 2. So that means that this distance here would have to be bigger than this distance here, which it's obviously not. So it's the third one here, it's this one here that I'm going to take. It's minus 2 minus 8, minus 2 plus 8. So you can see if this was 2 units, minus 2 here, and this could be 8 units up here. So this could be minus 2 here, and this could be 8. So that's it really. It doesn't say to give a reason or anything like that, I think. No, so that's it. Find the value of x for which h of x is a minimum. So they want us to find this value here, right in the middle that comes down to the vertex here. So they want to know what this x value here is. Well, that x value is halfway between minus 2 and 8. So in other words, if you take minus 2 and add 8 and, divide it in 2, you'll get minus 2 plus 8 is plus 6. 6 divided by 2 is 3. So that your x value would be 3. And that's it for this question. Okay, let's look at the next question, question 6. Tara buys a coat for 90 euros. She then sells the coat at a profit of 25%. Find the selling price of the coat. So if she buys the coat for 90 euros and she sells it at a profit of 25%, we've got to multiply this by 1 anyway. That'll just leave it at 90. But we've got to add an extra 25 or 0.25, if you like. 25% is just 0.25. So you got to multiply by 1.25, which will bring it up to 112.5 euros. That's the selling price. The margin on the coat is the profit as a percentage of selling price. Write down the profit for this coat and hence find the margin. Okay, so the first thing we got to do is work out the profit. The profit is just the selling price, which is 112.5. minus the cost price, which is 90 euros. When you do that, you get 22.5 euros. So that's the profit that she made on the coat. Now we've got to work out the margin. The margin is just the profit, which is 22.5, as a percentage of selling price. So we got to put it over the selling price, which is 112.5. We got to multiply that by 100. So when you do that, you get a margin profit, if you like, of 20%. So the profit is 22.5 euros and the profit is 20%. So let's look at the next one then. Write each of the following numbers in the form a by 10 to the power of n, where a is between 1 and 10 and n is an integer. So 58,000. So what have we got? We've got a decimal point out here at the end. We've got to turn that into a number between 1 and 10. So what you would do is change that decimal point and put it between 5 and 8. So now they're not equal anymore, if you like. So what we've got to do is make them equal again. So the way you do that is you multiply it by 10 to the power of the decimal point we put here. We've got to bring it back out here again. So we've got to move it 1, 2, 3, 4 places out there. So we multiply by 10 to the power of 4. So what we do is the same with this one here. The decimal point we can see there is between the two zeros. We've got to change that number to a number between 1 and 10. So we've got to put the decimal point here. 3.6 is between 1 and 10. Now we put the decimal point in here, so we've got to bring it back again. So we've got to bring it back 1, 2 places, but this time it's to the left. So we got to multiply by 10 to the power of minus 2 to bring it back to the left again. Okay, next question. Light travels at a speed of approximately 3 by 10 to the power of 5 kilometers per second. A light year is the distance traveled by light in 1 year. Find the distance traveled by light in 1 year. You may assume that there are 365 days in a year. Give your answer in scientific notation. So let's write down what we have. We have the speed. So we have 3 by 10 to the power of 5 kilometers per second. So you've just got to watch the units here. Let's see, the time then is what we have as well. So the time is 1 year. Now you've just got to watch the units here. We have our speed in kilometers per second. we have our time in 1 year. So what I want to do is change that 1 year to seconds. So 1 year is 365 days. So what I want to do is change that into hours. So what you do is you multiply 365 days by 24. So if you multiply 365 by 24, you get 8760, and that's hours. So we want to change hours into minutes. So what you got to do is multiply that by 60. There are 60 minutes in an hour. So if you do that, you get 525,600, and this is minutes. Next thing we got to do is change that into seconds. So again, there's 60 seconds in a minute, so multiply that by 60, and that'll give you 31536,000 seconds. Now we can change that into scientific notation just to make it a little bit easier. Bring the decimal point here. So it's 3.1536. Then we've got to bring it back again to the right 1, 2, 3, 4, 5, 6, 7 places. So that's how many seconds we're talking about in this question. Okay, so next thing then we've got to do is work out our distance. So if you remember Dad's silly triangle, we've got Dad's silly triangle. These two are multiplied here. So distance is speed times time. So the speed is 3 by 10 to the power of 5 kilometers per second. The time is 3.1536 by 10 to the power of 7. Okay, so what we can do here is multiply the 3 by the 3.1536. If you do that, you get 9.4608. And then you can multiply the 10 to the power of 5 by 10 to the power of 7. So you just add the two powers. That'll give you 10 to the power of 12. And this is distance. So we're talking about kilometers here. Okay, and that's it for question 6. Okay, so this is question 7. The diagram below shows the value of one share for company A in euro on the first day of each month from the 1st of January to the 1st of July. So we have to use the graph to estimate the value of one share on the 1st of March. So the 1st of March is here, and what you would do is you would come up along here, use a ruler, and then come across here. I'm getting somewhere, I'm going to say €7.30. If you use a ruler, it'll be a little bit below halfway between 7 and 8. I'm going to say €7.30. Okay, next question. Use the graph to identify the month during which the value of one share increased by the greatest amount. Okay, so if we look at the graph here, we need a line between 2 points that has the greatest slope. So we can see here, this part here, the line has the greatest slope. It's the steepest line. I'm going to say here between May and June. So I'm going to say here between May and June. So I'm going to say between May and June because it has the greatest slope. So during which, so it's the month of May, as the line has the greatest slope. Okay, next question then. On August the 1st, the value of one share was 15% lower than it was in 1st of July. By reading from the graph and doing calculations, estimate the value of one share on the 1st of August and calculate as accurately as possible, and hence plot that point on the diagram on the previous page. So we need to look at the 1st of July. The 1st of July we can see is this point here, and the shares had a value of €8. So what we've got to do is reduce that €8. We've got to take €8, reduce it by 15%. So what we've got to do is take 8 and multiply it by, if we multiplied it by 1, it would stay the same. So we've got to reduce it by 15%. So that's 0.85. 0.85 is 0.15 or 15% if you like, less than 1. So when you multiply that out, you get €6.80. So we've got to plot that on the graph. So it's €6.80. So let's see, where's that? That's going to be 680 is going to be somewhere around here. We've got to join that up here like that. Use a ruler again. Mine is not exactly straight, but use a ruler. And remember, all we did was we came up along here, and straight across here again using a ruler to €8. Okay, so next thing you've got to do then is later that year Liam predicts the value of one share. The error in his prediction is 150, which is a percentage error of 1630. Find the value of one share at this time. Give your answer correct in there, cent. So if we take 1630 percent, that's equivalent to an error of €1.50. So this is the error. Now what we want is the 100%. So what we do is we're going to go down to 1% and then we're going to go up to 100%. We want to know the value of the actual share at that time. So to go from 16.3 down to 1, divide 16.3 by 16.3, it'll give you 1. So divide the 150 by 16.3. And then if you want to go from 1 up to 100, you multiply 1 by 100. So do the same on the other side. So it's 150 divided by 16.3 times 100. So when you do that, you get a share value of €9.20. Okay, next one. The value of one share for company B can be modeled by the function P of M, which is 2 by 1.29 to the power of M, where P of M is the value of one share in euro and M is the time in months since the 1st of January. M is between 0 and 6. Complete the table below to show the values of P of M for the given values of M. Give each value of P of M correct 2 decimal places where relevant. Okay, so all you've got to do really is just stick 0 in here instead of M. That'll give you a P of M of 2. Put 1 in here instead of M. Put 2 in instead of M, put 3 in instead of M, and so on, and just do it on your calculator and write the values in here. So the values that I got are 2.58 for 1, 2.58, and then for 3 I got 4.29, for 4 I got 5.54, and then for 5 I got 7.14. Okay, so next question then. The graph of company A is shown below. On the same graph, draw the graph of P of M. So you just got to plot these points. So 0 is 2, so we're going to put a point here. 1 is 2.58, that's going to be somewhere around here. Let's see, 2 is 3.33, so 3.33 is, let's say, here. And then number 3 is 4.29. So 4.29 is around here. And then 4 is 5.54. That's somewhere around here. And then 5 is 7.14. 7.14 would be around here. And then 6 is 9.22, which is, let's say, here. So after that, then you've just got to join them up. You should get something like that. Okay, at only one point in the time period shown, the value of one share of company A is equal to the value of one share of company B according to the function P of M. In which month must this have happened? So if we have a look at this point here, this is where the two cross, so we can come down along here like this, use a ruler again, and we're looking at the month of March here. This is the month of March along here. So my answer here is March. Next question. According to the model, the value of one share for company B reaches its highest value on the 1st of July, and from then onwards it declines at a steady linear rate of 30 cents per month. A new function is created to model this decline, where Q of n is the value of one share n months after the time the share reaches its highest value. N is a natural number. Part of the function is shown below. Fill in the missing number in the box above to complete the expression for Q of n. So the value of one share for company B reaches its highest value on the 1st of July and then declines. So if we look at the 1st of July up here, we see a value of, this is July here, we see a value of 9.22. So that's here. So that's the number we need to put in here. So it reaches a value of 9.22 and then starts declining at this rate here, 0.3 cents, or 0.3 euros rather, 30 cents every month. So that was it for that one. Use your expression or otherwise find how many months it would take the value of one share for company B to fall below its value on the 1st of January according to the model. So the 1st of January, we look up here, On the 1st of January, we're looking at €2. So it needs to get below €2. So what you would do is you would take the 9.22 minus the 0.3n. So it's minus 0.3n. And you want that to be less than, it needs to fall below. So it needs to be less than €2. So you just got to solve this. So first thing I'll do is maybe take the 0.3n, bring it over to the other side. So I'm going to add 0.3n to both sides. So that's 9.22 is less than 2 plus 0.3n. The next thing I'll do is I'll get rid of that 2 on the right hand side. So I'll subtract 2 from both sides. So that's 7.22 on the left hand side. And it's just 0.3n on the right hand side. Next thing I'm going to do is I'm going to divide by 0.3 because the 0.3 is multiplied by the n. That'll get rid of it. I'll end up with 7.22 divided by 0.3, and that's 24.06 repeated. So our answer is 25 months. So it takes 25 months after the 1st of January to fall below €2 again. Because if you think about it, 0 to 1, that's the first month. 1 to 2 is the second month. 2 to 3 is the third month. So 24.06 is the 25th month. Okay, so that's it for part 2 and this question. Okay, let's look at the next question. Question 8. A company launches a new phone. The company's profit each year will depend on the number of phones it produces, X. The company's profit for the first year can be modeled by the function p of x equal to minus 1.5x squared plus 10.5x minus 4, where p of x is the profit for the first year in millions of euros, and x is the number of phones in tens of thousands it produces in the first year. X is between 0 and 7. X is real. Find P0 and explain what it means in the context of the question. Okay, so P of 0 is just going to be equal to minus 1.5 times 0 squared plus 10.5 times 0 minus 4. So when you do that, you will just get minus 4. So you get 0 here, you get 0 here. So what does it mean? It means that if the company produces 0 phones, they'll make a loss of 4 million euros. Okay, next question then. Complete the table below to show the values of p of x for the given values of x. So all you've really got to do here is take 0, put it in here and here. Take 1, put it in here and here. That's already done. Put 2, 3, 4, 6, and 7 in here instead of x and work out the values. So I have done that, and the values that I got are, so if I put in 0, we got minus 4. If we put in 2, should get 11. Put in 3, you get 14. 4 is 14. 6 is 5, and 7 is minus 4. So we have to plot these points now. So let's see, 0 is minus 4, so we're going to have a point down here. 1 is 5, so that's here. 2 is 11. So that is here. 3 is 14. So that's here. 4, 14 as well. 5 is 11, which is here. 6 is 5. That's here. And 7 again is minus 4. You just got to join these up then. Okay, you should end up with something like that. Hopefully yours is a little bit smoother than mine. But that's what we get. Use your graph on the previous page to estimate the range of values of x for which the company will have a profit of at least 6 million euros. Show your work on the graph. So 6 million euros. 6 million euros is here. So you got to come across here. And from here then we got to come down. Look at that value. And we've got to look at this value here. So I'm looking at here a range of about, let's say 1.1 up to 5.8. 1.1 to 5.8. So I'm going to say then that x is greater than or equal to 1.1 and less than or equal to 5.8. These are the number of phones they need to produce in order to produce a profit of at least 6 million. So it has to be equal to these values as well. Okay, so the profit of the company for the second year can be modeled by the function q of x equal to minus 1.5x squared plus 9.6x minus 3.5, where q of x is the profit for the second year in millions of euros, and x is the number of phones in tens of thousands it produces in the second year. This time x is between 0 and 7, x is real. Find q prime x, and hence find the value of x for which will give the maximum value of q of x. So what we've got to do is differentiate this. So if we have q of x is equal to minus 1.5x squared plus 9.6x minus 3.5. So we have to differentiate. So bring the 2 down, multiply it by the minus 1.5, that's minus 3x, reduce the power by 1 to 1. Take the 1 here, multiply it by the 9.6, so that's just 9.6, reduce the power by 1, so that'll give you 0. X to the power of 0 is just 1. If you differentiate 3.5, you'll get 0. So then it says find q prime x, which we've done, and hence find the value of x which gives the maximum value for q of x. So the maximum value is going to be given by minus 3x plus 9.6 equal to 0. You let it equal to 0. So subtract 9.6 from both sides will give minus 3x is equal to minus 9.6, and then divide by the minus 3 will give minus divided by minus is plus, so you'll get 3.2. So it's 3.2. These are tens of thousands of phones. So the value of x is 3.2, and these are tens of thousands of phones. Okay, then it says hence find the maximum value of q of x. So what will be the profit at this stage? So let's do that. Then we know our function is q of x, which is minus 1.5x squared plus 9.6x minus 3.5. So all we've got to do is do q of 3.2. So we're just going to put 3.2 in here. So it's minus 1.5, 3.2 squared plus 9.6, 3.2 minus 3.5. So when you do that, you just get 11.86. So it's 11.86, and these are millions of euros. Okay, so let's move on to the next question then. The profit for a third year can be modeled by the function R of x, where R of x is the profit for the third year in millions of euros, and x is the number of phones in tens of thousands it produces in the third year. X is real. The graph of R of x is shown, and x is between 0 and 6. So the first question is, at the start of the third year, the company receives 3 million in additional funding. As a result, the profit for the third year can be modeled by R of x plus 3. So it's just the profit plus an extra 3 million. From the graph, estimate R of 2, and hence work out the value of R of 2 plus 3. So R of 2 is just going to be, again, you'd use a ruler, and you would just come up along here from 2, and then across here. It looks like 8, so it's just going to be 8, and this is the profit, so it's in millions of euros. Okay, and then it says hence work out the value of R of 2 plus 3. So we have 8 here, and then in millions of euros, and then R of 2 plus 3 is just going to be 11 million euros. You just add 3. Okay, the last question then is, on the diagram above, draw the graph of y is equal to R of x plus 3 for x between 0 and 6 using the same axis and scales. Okay, so all we've really got to do here is just take each value, add 3. So let's go to minus 4, minus 3, minus 2, minus 1. Take 1 is here, so I'm just going to go up 3. 1, 2, 3. Be around there. 2 will be 1, 2, 3, somewhere around there. 11. This one here is going to be 1, 2, 3 around here. This one is 1, 2, 3 here. This one here is 1, 2, 3. And the last one then is minus 4, minus 3, minus 2, minus 1, which is here. So you just got to join these up. Okay, so that's my graph there. Again, it's a little bit shaky, but hopefully you guys will be able to do it a bit smoother than that. And that's it for this question. Okay, let's move on to question 9. Evan has saved 4,500 euros. He put this money in a savings account with a rate of 2.8% per annum compound interest. Find how much money will be in his account after 1 year. So really all you've got to do here is take 4,500 and multiply it by, there's two ways of doing it really. You can just do 2.8% on your calculator, work that out, and then add it on. But an easier way of doing it would probably just be to multiply it by 1, which will leave it as it is, and then add an extra 2.8%. Remember, 2.8% is just 2.8 over 100. So that's really 0.028. You're increasing it by 0.028. If you do that on your calculator, you get 4,626 euros. Okay, next question then. Hence or otherwise, find how much money will be in the account at the end of 3 years using a rate of 2.8%. Okay, so we can do this year by year. We've already done year 1. Let's look at year 2. We now know that we have 4,626 euros in our account. So we got to increase that again by 2.8%. So multiply it by 1.028. That'll give you 4,755.528. So what you do then is you look at year 3 and you take 4,755.528, multiply that by 1.028, and you should get, we have to do this to the nearest cent. So to the nearest cent, it's 4,888.68 euros. So this here would be the answer. The easiest way to do this, by the way, is to use a formula. There is a formula, F is equal to P 1 plus I to the power of T. This is the compound interest formula. So the principal, the original amount was 4,500. Multiply that by 1 plus, and you take 2.8% as a decimal, which is 0.028, and we're looking at 3 years here. So when you do that on your calculator, you'll also get this number up here. Okay, so that's the second part of that question. Let's look at part B. The pattern is made up of dots and line segments. The dots are evenly spaced on a circle. Each pair of dots is joined by a line segment. The first pattern has 2 dots and a line segment joining them. Each pattern has 1 more dot than the previous pattern. The diagram below shows patterns 1, 2, and 4. The dots in pattern 3 are below complete pattern 3. So this is just a case of joining up the dots here. So we can join that dot to that dot, this one to this one, this one to this one, this one to this one, and so on, until all the dots are joined up to all the other dots. So each dot is joined up to 3 other dots. Okay, so that's that one. Let's see, complete the table below to show the number of dots and line segments in the first 5 patterns of the sequence. The number of line segments in each pattern is in a quadratic sequence. Okay, so let's just fill out those numbers. So in pattern 1, there are 2 dots. We can see that. In pattern 2, there are 3 dots. So it seems to be always one more than this number here, the pattern number. So pattern number 1, there are 2 dots. Pattern number 2, there are 3 dots. 3, there are going to be 4. And so on, 5 and 6. The number of line segments then is in a quadratic sequence. But let's just see how many line segments we have in pattern number 2. In pattern number 2, we've got 1, 2, 3. We've got 3 line segments, so we can put 3 there. In pattern number 4, which is this one here, we've got 1, 2, 3, 4, 5, 6. We have 6. And in pattern number 5 then, if it's a quadratic sequence, we can have a look at that. You've got 1, 3, 6, 10. So if you look at the first difference, you got plus 2, plus 3, plus 4. So if you look here, you got plus 1 is the second difference. So if we add an extra 1 here, that'll be plus 5. So if you add 5 to 10, you get 15. So this would be 15 here. Okay, write down the number of dots in the 1,000 pattern. So you can see again here, as I said earlier, in pattern number 1, there are 2 dots, 2 there are 3 dots, 3 there are 4 dots, always 1 more. So the number of dots in the 1,000 pattern would be 1,001 dots. Okay, Sn is the total number of dots required to make the first n patterns where n is natural. Write Sn in terms of n. So Sn from your tables is n over 2 times 2a plus n minus 1 times d. So let's just stick in the numbers that we have for this pattern. N is just the pattern number, so we leave that alone. The first term was, this is the total number of dots. So if we look up here, the total number of dots here, the first term is 2. So we're going to put 2 in there for A. So it's 2 times 2 plus n minus 1. And we're really just adding 1 each time. So the difference, the common difference in that pattern is 1. So you just got to simplify this. So it's n over 2 times 4 plus n minus 1. And that's just going to be n over 2 times 4 minus 1 is 3 plus n. So this is our formula here for the total number of dots required to make the first n patterns. It's what you get when you add up all the dots up to pattern n. Okay, hence or otherwise, find the total number of complete patterns it requires in the sequence that can be made from 740 dots. So if we take our formula, Sn is equal to n over 2 times 3 plus n, 740 dots is Sn. So we can put 740 here is equal to n over 2 times 3 plus n. Now all we've got to do is solve for n here. So the first thing I'm going to do here is, because there's a 2 on the bottom here, I'm going to multiply both sides by 2. So that'll give me 1480 on the left and n times 3 plus n on the right. So if I multiply out the right hand side, I get 1480 is equal to 3n plus n squared. This is just a quadratic. So I've got n squared plus 3n. I've subtracted 1480 from each side. So you just got to work out what n is here. Now you can do this by factorizing, but because this number out at the end here is a bit big, it might be easier to use the quadratic formula. So n is equal to minus b. So remember, a here is 1, b is 3, and c is minus 1480. So it's minus b, so it's minus 3 plus or minus the square root of b squared, so it's 3 squared minus 4 times 1 times minus 1480. And that's all over 2a, which is just 2 times 1, which is 2. So n is equal to minus 3 plus or minus the square root of something over 2. When you do the bit underneath the square root symbol, you get 5929. 5929. And then that gives you two values for n. So it gives you n is equal to minus 3 plus the square root of 5929 over 2, which gives you 37. And then you also get minus 3 minus the square root of 5929 over 2. That gives you minus 4. Now we can't have a negative number of patterns, so that we don't use this one. So our answer is n is equal to 37. Now the other way of doing that is just simply to add up the number of dots and count the patterns. So the other way of doing this is just to add up the number of dots. We started with 2 dots, then 3 dots, then 4 dots, then 5 dots. See, and you know, this is pattern number 1, this is pattern number 2, pattern number 3, pattern number 4. And you can just add 2 to 3 and then add 4, then add 5, then add 6 until you, on your calculator, you get 740, and you just see which pattern number that is. But maybe that's an easier way of doing it, I'm not sure, but 2 ways of doing it there anyway. The formula for the number of line segments in term n is Tn is equal to 0.5n squared plus bn. Find the value of b, where b is a rational number. So we know that in term number 1, the number of line segments is 1. So if we come back up here, the number of line segments we can see in pattern number 1, there's 1 line segment. So I'm going to use this. N is equal to 1. Number of line segments equal to 1. So that's what I'm going to use. So in T1, T1 is equal to 1. So in other words, T of 1 is equal to 1, and that's equal to 0.5 times n, which is 1 squared, plus b times 1. So when you do this, you get 1 is equal to 0.5, 1 squared is just 1, plus b times 1 is just b. And then that gives you b is equal to, subtract 0.5 from each side, and you get 0.5 here. So B is equal to 0.5. That's it for this question. Okay, last question then, question 10. A factory makes closed boxes. The lengths of the sides of one of the boxes are shown in the diagram below. Draw a scale diagram of the net of the box in the grid below. Use scale 1 to 10. The length of each small square grid is 1 centimeter. Okay, so if we take, for example, this length here is 20 centimeters, that would mean we'd need to use 2 squares down here because each square is 1 centimeter. And if we multiply that by 10, it'll give us 10 centimeters. Multiply it by 20 will give us 20 centimeters for 2 squares. So let's draw the net. So I'm going to draw the back edge first. So it's this face but at the back, and that is 20 by 70. So we need 2 squares up and 7 across. So you guys need to use a ruler here as well, by the way. So now I'm going to draw the bottom part. The bottom part is 30 by 70. So I'll just close that off. So I need 30, 1, 2, 3 by 70. Now I'm going to draw the 2 edges. So this edge here and the edge on the other side as well. That's 30 by 20. So we need to come out 2, come out 2. So that's the back and the bottom part. Now we need to draw this face here. Front face, that's 2 by 70. So it's another one of these. Down here, just 2 squares. And here. And then last face then is going to be the top part here, which is 70 by 30. So we need to come down 3 and across 7. And that is it. So again, as I say, you guys need to use a ruler when doing this. Okay, next question. Work out the surface area of this box in square centimeters. Okay, so what you need to do here is find the area of one face and double it, find the area of another face and double it, and then find the area of another face and double it, because there are 2 of each of these 3 faces. So it's going to be 70 by 20. So the surface area here is 70 by 20, and there are 2 of those, plus, so 70 by 20 is this face here. Let's do the side face, 30 by 20. So it's twice 30 by 20, and then it's twice this face here. We'll do the top and the bottom now. That's 70 times 30. So 70 times 30. So it's just a lot of calculator work. And when you do that, you should get 8200, and it's area, so it's centimeters squared. The factory owner buys a machine from China for making the boxes. The machine costs 353,819.34 Chinese yuan. Including shipping. The factory owner must also pay 1,890 in customs duty. Using the exchange rate, €1 is equal to 7.61 Chinese yuan. Find the total cost of the machine in euro, including the customs duty. So write down the exchange rate, put what you're looking for on the right hand side. We're looking for euros, so put 7.61 on the left hand side and put the euro on the right hand side. We want this many Chinese yuan, so we want to go down to 1 and then up to 353,819.34. So to go from 7.61 down to 1, you need to divide by 7.61. So divide the right hand side by 7.61. Then multiply to go from 1 up to 353,819.34. Multiply, so it's 1 over 7.61 multiplied by 353,819.34. So when you do all of that, you're going to get 46494 euros. Now there's also a customs charge, so you got to take 46494 and add 1890. When you finally do that, you get your answer, which is 48384. So 384, and that is in euros. This is the answer here. Okay, next one then. Kira gets paid a wage of €780 per week for working 40 hours. She also gets paid an hourly rate for any hours worked over 40 hours. This rate is 50% more than the hourly rate for the first 40 hours. On a particular week, Kira works her regular 40 hours plus an additional N hours. Her total wage is 1,043.25. Work out the value for N. So the first thing we're going to do is we're going to take the €780 and work out Kira's normal everyday hourly rate. So if you take the 780, she works 40 hours, so divide by 40. That gives her an hourly rate of 19.50, €19.50, and that's per hour. Now this is her standard week rate. Now to work out the overtime rate, if you like, if she works anything over 40 hours, take the 19.50 and then you got to multiply that. You got to increase that by 50%. So multiplying it by 1 will leave it as it is. Multiplying it by an extra 0.5 will give you the extra rate then. That is 29.25 euros. So this is, and that's per hour. This is the overtime rate. Okay, so she works a normal week and then she works overtime. She gets paid 1043, so she gets paid 1043.25. Let's see how much overtime she actually got paid. So subtract the normal week's wage. That gives her an overtime payment of 263.25. So this is how much she got paid for the entire week, but this is how much overtime she actually did or she got paid for. So we want to take the 263.25 euros. So we want to know how many hours she actually worked overtime. So we got to take her overtime pay divided by the hourly rate, which is 29.25. And that gives you a number of hours that she actually did overtime, which was 9 hours. So that's equal to the N then. Okay, next question. A shop repairs clothes. A charge for a repair is given by the formula C is equal to 20H plus XH over D. C is the charge for the repair in euros. H is the number of hours it took to do the repair. X is an extra hourly charge based on the level of difficulty of the work, and D is a discount rate, and D is greater than 1. Find the charge for repair when it takes 3 hours to do the repair. An extra hourly charge X is 3.5 and discount rate D is 1.1. So this is just a case of writing down the formula, which is 20H plus XH over D, and then just sticking in the numbers that were given. So it's 20 times H then is the number of hours it took to do the job. So in this case, it took 3 hours. So it's 3 plus X is the extra hourly charge based on the level of difficulty. In this case, it's 3.5. You got to multiply that by H, which is 3, and then divide by the discount rate. In this case is 1.1. So when you do this one, you get to 2 decimal places. You should get 64.09, and that's in euros. Next question then. Find the value of X when the charge for the repair is 76 euros. It takes 4 hours and a discount rate is 1.2. This is kind of working backwards kind of question. You're given the answer. You're told the repair is 76. It takes 4 hours, so it's 20 times 4. Plus, then we've got to write down the X. We don't know what that is. 4 goes in there, and the 1.2 goes in there. Okay, so the first thing you would have to do is get rid of that 1.2. So take the 76, multiply by 1.2, and that gives you on the left-hand side 91.2, and that's equal to 4 20s, which is 80, plus 4x. So the next thing you're going to do is subtract 80 from both sides. So if you subtract 80 from the left-hand side, you get 11.2. And then on the right-hand side, you've got 4x. And the last thing you're going to do is just divide both sides by 4. So if you divide the left-hand side by 4, you get 2.8. And that's your value for x. Okay, next one then. In the formula for C above, D is bigger than 1 or equal to 1. What impact would changing D so that D becomes less than 1 on the charge for the repair? So if we look at our formula is what is it, C plus 20H. So it's C is equal to 20H plus X times H over D. Now we want to change D to a number that's less than 1. We want to make this number smaller. So making D less than 1 would make the fraction bigger. So the cost would increase. So the cost for repair C would increase. Okay, and that's it for this question and this paper.